Following on from the previous video, we assumed that e can be expressed as a fraction. Now, if e can be expressed as a fraction, then this quantity here must be a whole number. Well, as it turns out, this quantity here is not a whole number. So therefore, we have to go back to here and say that e cannot be expressed as a fraction. So in this video, we're going to understand why this cannot be a whole number. So that's the idea behind proof by contradiction. So following on from the previous video, we got to this stage here. So we would consider this quantity. We would consider looking at this quantity. We would break this up into one block, and then this here to another block. So this one goes all the way to infinity. So this whole thing here is, we're just going to call it A, and then the remainder will be this whole block here. So in the previous video, we got to this stage here. So now if you look at this, so depending on where you truncate it, let's say you truncate it here, then the next term will be a positive. If you truncate it, let's say here, then the next term will be a negative. So if you look at this, here you've got you see by rewriting this as this. So this is your A here. This is your A, and then the whole block here is this whole block here. You see, this component here will take into account where you truncate it. So for example, if you truncate it here, the next term will be a minus. So this component here will take into account this minus. If you truncate it, let's say here, the next term will be a positive. This component here will take that positive into account. The beauty of this is that up here, you've got 1 to the power whatever, minus 1 to the power whatever. Here you've got 1, 1, 1, 1. It's nice and simple. And then you've got your minus, plus, minus, plus. This component here will take the adjustments into account. So when you truncate it, no matter where you truncate it, this component here will take the sign into account. Well, I've not explained it very well, but from here you can jump to here. Okay. So now you might have to think about it. So now you've got one block, and then you've got another block. So here you've got one block and another block. Now if you look at this, this times this, this times this, this times this, and so on. Let's just look at this case here as an example. So here you've got m factorial, you've got m factorial over m plus 2 factorial. So that would be m plus 2 times m plus 1 times m factorial. So these two will cancel out, leaving you 1 over m plus 2 times m plus 1. So from here, that will then take you to here. So now if you look at this, what you've got here is an alternating series. So remember, with an alternating series, let's say you've got an alternating series here. Well, when you have an alternating series, the remainder, so remember, this is our remainder. This is so remember, going back to here, hang on. So going back to here, we would consider this quantity. So we would cut up here, and then so this here is your remainder. So you've got this times this. Well, whenever you have an alternating series, there's a theorem that says the remainder must be less than this one quantity here. Must be less than this one quantity here. Let me just give you a quick reminder. Let's say you've got an alternating series. Let's say you cut it right here, you truncate it here. So this here is your remainder. This here is your remainder going all the way to infinity. Well, if you sum up everything, the remainder must be less than or equal to this number 8. Because if you think about it, here you've got 8. So here you've got 8, the remainder is 8, and then you take away a number that's less than 8, and then you add a number that's less than the previous one, so here, and so on. It's going to be, well, the remainder, if you sum up everything, the remainder must be less than 8. If you truncate it, let's say right here, then here you start at negative 5, and then you add a number that's smaller than 5. So 4, that will take you to here. Take away a number that's smaller than the previous one, and so on. You're going to get something looking like this. If you sum up everything, then then it must be less than whatever this value is. Well, there's a theorem that says that. So here you've got an alternating series. Well, an alternating series. Then if you look at the remainder, so this here is your remainder. So your whole of everything, take away a. Well, basically this thing here will be your remainder. Your remainder. There's a theorem that says your remainder must be less than or equal to the value of the very first term here. So that would be this. Well, this value here is less than 1. So what it's saying is that your remainder is less than 1. So hang on, going back to here. If your remainder is less than 1, hang on, let me think. So looking at our example here, let's say you truncate it here. So this thing here, we said that this thing here is a whole number. Now, if the rest is 1, then if this thing here is a whole number, if this thing here, well, this thing here is it has to be less than 1 because of this, because it has to be less than 1. Hang on, I'm not explaining this very well. Bear with me. So let's say you truncate it here. If this whole thing here is a whole number, which we've established, this thing here is a whole number. If the rest is a number that's less than 1, but it's not a whole number. Well, if it's less than 1, let's say 0.3 here, then the whole number plus 0.3, then you can say that this thing here is not a whole number. So therefore, this thing here is not a whole number. If the remainder here, remember we've already established that this thing here must be a whole number. Well, if the remainder here is less than 1, is between, well, if the modulus is less than 1, then let's say 0.983 here, then you've got a whole number plus this thing here. Then you can conclude that this thing here is not a whole number. If the remainder is 0.003, then if this thing here is a whole number, and then you add a weird number, then this thing here cannot be a whole number. So going back to here, we are saying that e can be expressed as a fraction. If e can be expressed as a fraction, then this must be a whole number. Well, we've just seen that this thing here is not a whole number, so we have to go back to here and say you cannot write e as a fraction. So e is irrational. Okay, I hope you can follow that.